Most Azure administrators are one compromised credential away from a tenant-wide breach, and it's not their fault, it's the architecture. The evidence for that statement has been made publicly at the highest level. Microsoft's own Secure Future initiative, launched in direct response to a series of incidents that became public record, explicitly identifies privileged access hygiene as a first-order security priority. These aren't theoretical failures, they're documented ones. In the next half hour, I'm going to show you an architecture that makes that scenario so difficult that most threat actors simply can't afford the attempt. Here's the complete bottom line. A properly hardened privileged access management architecture for Azure has 5 layers. A dedicated hardened workstation you don't use for anything except administration. Cloud session isolation so your admin activity never touches your physical device. Private-only Bastion with no public IP whatsoever. Time-bound RBAC elevation through Entra privileged identity management, and time-bound network port control through Defender for Cloud JIT VM access. So there are no standing permissions and 0 open management ports when administrative work is not taking place. Underpinning all of it, a break glass account that is itself secured to a standard that doesn't create the very backdoor it's supposed to protect against. Each layer stops a specific class of attack. Each can be adopted independently, and I'm going to tell you for every single one what it actually protects, what it costs, and who genuinely needs it, so you can make a deliberate decision instead of defaulting to whatever is easiest to configure. Here's why I'm building this from the endpoint up rather than starting with identity controls. Think of it like this. A password is a secret code that anyone who learns it can use. Traditional MFA adds a second check, proving you also physically possess a specific device. A passkey goes further. It's a cryptographic key bound to a specific device that cannot be phished or replayed. But privileged access management, done properly, is like a bank vault that requires 2 different keys held by 2 different people inside a room you can only reach through 3 locked doors, on a timer that opens for exactly 60 minutes before the doors lock themselves again. None of those controls individually are unbreakable. The point is that together they make the cost of an attack so prohibitive that a rational threat actor moves on to someone who didn't build the vault. Now, let me show you the 5 layers, what they protect, what they cost, and this is the part most architecture content skips, which ones your organization actually needs. The architecture starts at the endpoint for a very simple reason. Every privileged access session, every single one, originates from a device. If that device is compromised, you're operating inside the attacker's perimeter before you've even taken a single administrative action. A privileged access workstation is a single-purpose device. No email, no Teams, no web browsing. Administrative tooling only. Azure Portal, PowerShell, Azure CLI. That restriction is the entire point. The hardened stack, Windows 11 Enterprise with Credential Guard enabled. This is the control that prevents NCLM hash extraction and Kerberos ticket theft from process memory. It eliminates the most common credential theft techniques right at the operating system level. Windows Defender Application Control locks down execution to explicitly approved tooling. BitLocker encrypts the disk. Local administrator rights are removed entirely. Now here's the mechanism that actually matters. The POR is enrolled in Microsoft Intune and Entra ID joint. This activates a conditional access policy that evaluates, at every single authentication, whether the device attempting to connect meets a defined Intune compliance profile. That profile specifies Credential Guard is active, BitLocker is enabled, the operating system is above a minimum version. There's no active threat detections from Defender for endpoint, and no local admin rights are configured. A device that fails any one of those criteria is not warned, it's blocked. The POR isn't trusted because it's a dedicated device. It's trusted because it continuously proves its compliance posture to Entra ID and conditional access enforces that proof every time. Now, device compliance is a static check. It answers one question: is this a known managed compliant device? What it doesn't evaluate is whether that particular sign-in is behaving normally. And those are two different questions. Microsoft Entra ID protection adds a dynamic layer. It scores every authentication event in real time against a risk model drawing on Microsoft's global threat intelligence, detecting impossible travel, unfamiliar sign-in properties, anomalous token behavior, and credentials appearing in known breach datasets. When ID protection flags elevated risk, a risk-based conditional access policy can automatically block the sign-in or escalate to step-up verification, even if the device passes a standard compliance check. This matters because a compromised POR with an active session would pass device compliance. It would likely fail an ID protection risk evaluation the moment the sign-in pattern becomes anomalous. The static check and the dynamic check are complementary, not redundant. One licensing note. Risk-based conditional access policies require Entra ID P2. You'll already need P2 for PIM later in this architecture, so in most deployments, this capability comes at no additional license cost. But it does need to be explicitly configured. Licensing is not the same as enabling. Who needs this layer? Any organization where administrative accounts manage systems whose compromise would cause material damage. That's most enterprise environments. The cost is primarily device procurement and in-tune configuration overhead. Both are manageable. This is the layer with the highest return on investment in the entire stack. Now, stop for a moment. The POR with conditional access device compliance is genuinely the most impactful single control in this entire architecture. Everything that follows amplifies it. But if you implement nothing else from this video, implement this layer. That said, a POR is still a physical device in the real world, and your administrator still needs somewhere to actually work. That's where layer 2 comes in. The POR eliminates the local endpoint as an attack surface, but the administrator still needs to interact with Azure. And we want that interaction to happen inside a controlled cloud environment, not directly from a device that, however hardened, still exists in the physical world. This is the job of Azure Virtual Desktop. The AVD session hosts live inside a dedicated management VNet in Azure, completely isolated from production workloads with no peering to the data plane. The administrator connects from the POR to AVD via RDP over HTTPS. The critical detail: session data never lands on local storage. Clipboard policies are enforced, file transfer is controlled. The only thing that physically moves between the POR and the AVD session is screen pixels. Once the administrator is inside that cloud desktop, they're operating inside the Azure network boundary. Connectivity from the management VNet to production resources flows through a hub and spoke architecture, a hub VNet housing Azure Firewall with spoke VNets for production workloads. Every connection transits that firewall, which enforces exactly what is and isn't permitted. And because conditional access also applies to the AVD authentication, requiring that compliant POR, we now have dual verification. Right device, right user, right session environment. 3 separate checks before anyone touches anything. Now, a design upgrade worth naming. What I've described, a management VNet in a single Azure tenant, is the baseline, and it's sufficient for most enterprise environments. But for organizations with the highest sensitivity requirements, there's a further step. Deploying the management plane to a separate dedicated Azure tenant. The AVD hosts, the Bastion, all administrative tooling. Everything lives in a management tenant with no production workloads and no data assets. Production stays in a completely separate tenant. The two are connected only through Microsoft Entra cross-tenant access policies and for resource delegation, Azure Lighthouse, both of which give you explicit, auditable control over exactly what crosses the tenant boundary. The security gain is significant. A credential compromised in the production tenant grants zero access to the management tenant and vice versa. The blast radius is bounded at the tenant boundary. The cost is also significant. separate tenant operations, cross-tenant identity governance, additional licensing. This is the right choice for organisations managing critical national infrastructure or financial market systems, environments where a nation-state threat model is realistic. For most enterprise environments, the single-tenant hub-and-spoke architecture is the correct starting point, with tenant separation as a planned evolution. Who needs this layer? Session isolation through AVD is appropriate for regulated sectors and organisations with significant Azure management footprints. The separate management tenant upgrade is for the high sensitivity tier only. I've shown you how to harden the endpoint and isolate the session. The administrator is now working inside a locked-down cloud desktop, authenticated through a channel that enforces device compliance at every step. But they still haven't actually connected to a virtual machine yet. And the way most organisations handle that connection, even well-run organisations, leaves an unnecessary attack surface in place. I'll show you exactly what that surface is and how to remove it completely after this. The traditional model for VM access is a jump server with a public IP address protected by NSG rules and firewall policies. The fundamental problem is simple. A public IP is reachable from the internet by definition. You can restrict who can reach it, but the surface is there. And jump servers have a poor track record. Over time, they accumulate technical debt, missed patches, over-permissive rules. Azure Bastion in private-only deployment removes the problem at the root. Private-only Bastion is deployed with no public IP address. None. It's entirely non-internet routable. Access occurs via private IP only from within the VNet. In this architecture, that means the administrator, already inside the AVD cloud session within the management VNet, initiates the Bastion connection entirely within private Azure networking. In a private-only deployment, Bastion also doesn't permit outbound access outside the virtual network. The boundary is closed in both directions. The target VMs, no public IP addresses either. They're not reachable from the internet at any layer. Two implementation specifics that matter. First, private-only Bastion requires the premium SKU. This is not optional if you want private-only deployment. The premium SKU also enables session recording. Every administrative session is captured and stored. That recording is your evidence trail for incident response, your compliance artifact for audit, your forensic record. For any organisation operating under regulatory requirements, session recording is not a nice to have, it's mandatory. Second, because there's no public IP, the Azure portal, itself a public web application, cannot initiate Bastion sessions. Connection must be made through the Bastion native client running from within the AVD session. This is an operational consideration, but it also reinforces the architecture. The only valid path to VM access runs through the entire secure session chain. Who needs this layer? Any organisation with virtual machines that currently have public IPs or jump servers with public exposure. The standard SKU Bastion with a public IP is a meaningful improvement over an exposed jump server. It removes direct port exposure. Private only on the premium SKU is the appropriate endpoint for sensitive environments. So far, I've shown you how to eliminate the endpoint as an attack surface, isolate the administrative session inside the cloud boundary, and remove public IP exposure from your virtual machine access layer completely. What I haven't addressed yet is the most persistent, most exploitable risk in privileged access, standing entitlement. An account that holds a permanent administrative role, even if every other control in this architecture is correct, is a 24-hour target. Here's how to eliminate that entirely. Standing privilege means this: an account has permanent admin permissions. If those credentials are compromised at any point, even when no admin work is happening, the attacker has immediate, unrestricted access to everything that account can touch. The solution is zero standing privilege. And in Azure, you implement it through two independent mechanisms that operate at completely different planes. The first is Entra Privileged Identity Management, PIM. This is layer 4. It operates at the identity and RBAC plane. In a correctly configured deployment, no admin account holds a standing RBAC role. Instead, accounts hold eligible assignments, the right to request elevation, but not permanent access. When an admin needs to perform work, they activate a role through PIM. They provide a justification. For high impact roles, owner and contributor at subscription scope, an approver must review the request. Phishing resistant MFA is enforced at activation, regardless of what MFA was used at sign-in. The role is granted for a defined window, typically 1 to 4 hours. When that window expires, the role is automatically revoked. There's no manual deactivation step. There's no possibility for forgetting. Every activation is logged. Who requested it, which role, which scope, what justification, when, for how long, who approved. That's your accountability layer and your audit trail. One capability worth noting as PIM has matured. It now governs not just RBAC role assignments, but group membership through what Microsoft calls privileged access groups. If access to a resource in your environment is controlled by an Azure AD security group, common in hybrid or legacy configurations, PIM can apply the same eligible assignment model to that group membership. The same justification requirements, the same approval workflows, the same time-bound access and automatic expiry, the same audit trail. If your environment routes access through group membership rather than direct role assignment, this is the control that closes that gap. Let me pause here for a moment, because the distinction between these two layers is where most architects lose the thread. PIM operates at the identity plane. It answers one question: does this person have permission to do this thing right now? JIT VM access operates at the network plane. It answers a completely different question. Is there even a path to reach that resource in the first place? You need both answers to be yes, and you need them both to be yes only when administrative work is actually happening. That's where layer 5 comes in. The second mechanism is Defender for Cloud JIT VM access. This is layer 5. It operates at the network plane. Even with private-only Bastion, the VMs behind it have NSG rules that govern whether management ports RDP on 3389, SSH on 22, and WinRM on 5985 and 5986 are open or closed. JIT VM access manages those NSG rules dynamically. By default, with JIT enabled, those ports have an explicit deny rule. They're closed. An attacker who somehow reached the private network can't connect. There's no open path. When an administrator needs to connect via Bastion, they submit a JIT access request. The service creates a temporary NSG allow rule scoped to the specific source IP address of the Bastion host for the duration of the requested session only. When the window expires, the deny rule is reinstated automatically. No manual cleanup, no port left open. Here's why you need both. PIM without JIT VM access removes standing RBAC permissions, but the network ports are still open. A threat actor who reaches the network can still reach those ports. JIT VM access without PIM closes the ports, but the RBAC entitlement remains permanently active. A compromised credential can be used to request JIT access, and the system has no obligation to flag that as unusual if the account already has standing RBAC rights to make that request. Together, they create zero standing privilege at both planes simultaneously. No open ports, and no active RBAC permissions when administrative work is not taking place. This is the complete picture. Who needs this layer? PIM should be considered a baseline requirement for any organization with Azure resources managed by human administrators. The cost is an Entra ID P2 license, included in most enterprise Microsoft 365 plans. JIT VM access requires Defender for Servers Plan 2 on protected VMs. For environments where VM compromise would be high impact, this is the appropriate control. For lower sensitivity environments, PIM alone may be proportionate. If you're managing regulated data, this next section matters more than any other, because every architecture that removes standard privilege creates a dependency. And when that dependency fails during an incident, you need a path back in that doesn't destroy the security you've just built. Any architecture that eliminates standing privilege through PIM and requires conditional access device compliance to authenticate creates a real operational dependency. If Entra ID has an outage, if the MFA infrastructure fails, if every pore in the organization is unavailable during a critical incident. Without an emergency access path, a security incident becomes compounded by an operational lockout. You need a way in, but that way in cannot be the weak point that undoes everything else. Here's what a properly constructed break glass configuration looks like. Account design. Break glass accounts must be cloud only, not synchronized from your on-premises Active Directory. They should use the .onmicrosoft.com domain suffix, not your federated domain. That way, a failure of your on-premises identity infrastructure or federation service can't affect them. Create 2 accounts, not 1, independent. No shared credentials, no shared hardware. Authentication. These accounts must not use phone-based MFA, authenticator apps, or anything that requires an operational third-party service. The authentication must be a FIDO2 hardware security key, a physical device requiring physical possession. 2 accounts means 2 separate FIDO keys, stored in 2 separate physically secured locations. A safe, a vault, a sealed envelope in a signed-for deposit box. The credentials themselves, account names and passwords, should be printed on paper and stored physically alongside the keys. Do not put them in a password manager. Do not put them in a cloud service. No remote access path to the credentials whatsoever. Exclusions. These accounts must be explicitly excluded from all conditional access policies, including the device compliance requirement. They must also be excluded from PIM. In an emergency, you need immediate access, not an activation workflow that may itself be unavailable. Now, I need to be direct here. This is where the risk becomes real. Excluding accounts from conditional access and PIM means those accounts have standing global admin rights, accessible from any device, with a FIDO2 key as the only barrier. That's why the physical security of that key is the critical control. An account that requires physical possession of a specific hardware device stored in a secured physical location is not weaker than your poor workflow. It's just differently protected. The attack model has shifted from network and credential based to physical. For most threat actors, including sophisticated ones, physical access to a secured corporate facility is a dramatically higher bar than a credential attack. Monitoring. Every single sign-in from either break glass account must generate an immediate real-time alert, not a daily digest, not a weekly report. The moment that account authenticates, your security operations team, your CISO, and the relevant stakeholders are notified. In normal operations, these accounts should never be used. Any sign-in is by definition an event requiring immediate investigation, either a legitimate emergency or an active breach. Microsoft Sentinel or Defender for Identity provide this alerting with low implementation overhead. Testing. Test the break glass configuration at minimum annually. Verify that the accounts can actually authenticate, that the FIDO2 keys work, that the alert fires correctly. An untested break glass account that fails during an actual emergency is worse than not having one. It creates false confidence. The honest summary on break glass accounts is this. They are a necessary compromise in any architecture that eliminates standing privilege. The goal is not to make them as restricted as your poor workflow. The goal is to make the specific attack path they create, physical compromise of a hardware key in a secured corporate facility, significantly harder than any alternative path in your environment. If you implement the guardrails I've described, that goal is achieved. Let me bring everything together, because the architecture only matters if you know which pieces apply to you. The first thing to understand is that privileged access is not a binary choice. It's a spectrum. Where you sit on that spectrum should be a deliberate decision based on three things: the sensitivity of what you're protecting, the sophistication of the threat actors likely to target you, and the cost, in money, in complexity, in friction, your organization is willing to accept. At one end, community workloads, internal business systems, collaboration tools, non-sensitive data. Entra PIM plus conditional access device compliance, low cost, standing privilege eliminated, administrative accounts locked to managed devices. That is a meaningful security uplift over the default, and it's where every organization should start. In the middle, regulated data, financial systems, healthcare records, critical infrastructure dependencies. You benefit from the full POR, AVD, and Bastion architecture, the first three layers with PIM and JIT VM access for zero standing privilege at both planes. The cost is real: hardened endpoint procurement, Bastion premium SKU pricing, operational overhead, but so is the regulatory exposure if something goes wrong. At the far end, organizations whose threat model includes sophisticated nation-state actors, or where a control plane breach would be catastrophic. These organizations benefit from all five layers, including management-tenant separation. The architecture I've described today represents this end of the spectrum in full. Before the attack path analysis, there is a scope boundary I want to name explicitly. Everything in this architecture addresses human privilege access, the path an administrator takes to reach and operate on your Azure resources. But admin access is increasingly not just human. Service principals, automation accounts, deployment pipelines, CI/CD systems. These are non-human identities, and they need the same least privileged discipline as your human administrators. The principle is unchanged: no standing high privilege credentials. Use managed identities wherever Azure supports them. They eliminate the credential management problem entirely, with Azure handling the authentication lifecycle. For service principals where managed identities aren't an option, apply certificate-based authentication, time-bound secrets, and regular rotation. Non-human identities are an increasingly targeted attack vector, and they're frequently left outside the scope of a PAM program. The architecture you build for human administrators needs an equivalent program for your workload identities. This is a separate video, but I would be doing you a disservice not to flag it here. And a practical starting point before you begin: run your Microsoft Secure Score. It evaluates your tenant against many of the controls we've covered today and gives you a scored gap analysis. It's also one of the most effective tools for communicating security posture to senior management. A measurable number that tracks visible progress as each layer is implemented. Use it as your baseline. Use it as your reporting instrument. Start there before you spend a penny. For a threat actor to reach an administrative target in the complete architecture, they would need to physically compromise an Intune compliant, credential guard hardened POR, bypass Entra conditional access device compliance verification and ID protection risk evaluation simultaneously, compromise an AVD session inside a locked-down cloud desktop, traverse hub and spoke network controls enforced by Azure Firewall, reach a Bastion host with no public IP address, connect to a VM with management ports closed by default, do so within a window where PIM has been activated, which itself generates an audit alert, using credentials requiring phishing-resistant MFA, and do all of this without triggering the continuous monitoring stack. That is a genuinely difficult attack path. That is what defense in depth means in practice. Not that any single control is unbreakable, but that the combination of controls makes the cost of a successful attack prohibitive relative to most threat actors' resources and objectives. The question for your organization is, how many of those layers are proportionate to your risk? Make that decision consciously. Document it. Review it when your risk profile changes. The complete architecture maps directly to Microsoft's Enterprise Access Model, the NIST SP 800-207 Zero Trust Architecture Framework, and the Microsoft Cloud Security Benchmarks PA2 and PA6 controls. For UK organisations specifically, it aligns with NCSE guidance on privileged access management and cloud security. And for any business working towards or maintaining Cyber Essentials Plus, the baseline controls in this architecture, PIM and Conditional Access Device Compliance, directly satisfy the access control requirements for that scheme. This is the documented standard, not a vendor recommendation, not an opinion, the standard. Here is the professional secret. At the end of the day, cybersecurity isn't about being unhackable. It's about making yourself such a difficult target that an attacker moves on to someone else. Identity is the new perimeter. If you don't own your identity, you don't own your data. If you want to go deeper on any individual layer, the in-tune configuration for port hardening, the hub and spoke network topology implementation, the PIM role settings, and approval workflow design, let me know in the comments. I'll prioritise the implementation walkthroughs based on what you most need. If you're responsible for privileged access architecture in your organisation, share this with the decision makers who control the investment. The conversation about which layers to implement is a lot easier when everyone in the room understands what each layer actually does. Do me a favour, hit that like button so this video reaches more people who might be at risk. Subscribe if you want the full series. I'm here to help you navigate the complex world of cybersecurity, one practical step at a time. I'll see you in the next one.